my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope you can hear me and see the screen. If you can't see it, please let me know. I will adjust the brightness. Okay, so now let's see. Before I start, I just wanted to tell you what is the blueprint of this chapter. Okay, so the blueprint of, we are going to discuss one of the most important chapter of your PU2 exam, and that is current electricity. So if you see the weightage of the chapter, that is basically 13 marks. So 13 marks will come from this chapter alone. Okay, now what is the marks distribution from this chapter? The marks distribution from this chapter, one marker MCQ question will come, one question will come as a 1 marker. That means that definitely will be MCQ. Fill in the blanks will not come from this chapter. There will be a 2 marker question and 2 5 marker question. Okay, so 2 5 marker question means 1 5 marker theory question and 1 numerical, both will come from this chapter. This is one of the most important chapter. Even the MCQs are not going to be easy for this chapter, right? So this is the basic blueprint layout, and if you are wondering, sir, what type of numerical questions are going to come, then that is not sure. There are a lot of different varieties of numerical questions coming from this chapter. That can be a circuit diagram based question, that can be a simple cells combination based question, or it can be a unbalanced Wheatstone bridge question. So unbalanced Wheatstone bridge I have covered in one of the lives before. So if you want to check that out, you can check that out in a later part. So this is all, this is the most important chapter of your PU2. Now what we are going to do today, we are definitely not discussing the blueprint. We are going to discuss, yes, we are going to discuss the we are going to discuss the MCQ question from your model paper, question bank, right? So let's see if you can see the model paper or not. Let me change the layout. Right now I think, okay, it's not coming. Now it is visible, right? I hope it is visible. Preksha saying, sir, not able to hear. If you are not able to hear, please check your sound. I think my voice is quite okay from here. Yes, because I can see my yes. Preksha, please check your voice, and if anyone else is facing the sound issue, please let me know. Because I can hear myself in the stream that I am here. Okay, so if you still have any issue, check your audio connection, the Bluetooth, maybe you are listening from Bluetooth, or the sound of your mobile or laptop is turned off. Check that. Okay, Komal is saying no sound issue. Thank you, Komal. Now let's see the questions. We will solve all the MCQs. Worry not, all easy, difficult, medium difficult. Okay, we will solve everything from all the 1 marker question. Okay, so first let us start with the first question, and as you can see here, it is mentioned E. E stands for easy question. Okay, so first question, the SI unit of electric current, the most easiest question. Options are coulomb, ampere, volt, farad. Okay, so obviously Manshi is saying that her saying low voice. Okay, let me increase my voice a little bit. So I have increased the voice a little bit, so if you still have any issue, you can check. Okay, Mansi is saying option B, yes, ampere is the correct answer. Somehow my pen is not working. Yes, So option B is correct. Ampere is the correct answer for this question. So Mansi, Divya, Komal, Kaushik, everyone answered 1B. Good evening, Mayuri. How are you? So now next question, let's move on to the next question. So the first question is generally easier. First few questions will be easier. We will solve it quickly. And as we move on, we will see some difficult questions. Okay. When no current is passed through a conductor, the free electrons do not move. The average speed of free electron over a large period of time is not zero. The average velocity of free electron over a large period of time is zero. The average velocities of all free electron at an instant is non-zero. Let's see which one of the option is correct. So nothing is given, that means one is correct. Okay, so you have to choose the correct option. Ishan is saying option C. Subbu Yadav, welcome Subbu. So what is the correct answer here? So obviously electrons are always in constant motion. Okay, no matter current is passed or not passed. Okay, if current is passed, they start to drift in particular direction, but average velocity of free electron over a large period of time when no current is passed is zero. So that means correct option is C. It is zero. Okay, so when current is being passed over a large period of time, the average velocity is zero. Now let's see the question number 3. Is it an easy question? Yes, it is also an easy question. In the absence of an electric field, let me zoom out a little. In the absence of an electric field, the mean velocity of free electrons in a conductor at absolute temperature T is in the absence of an electric field. So what is the meaning of absence of electric field? Again the same thing, no current is flowing. The mean velocity of free electrons in a conductor in a absolute temperature is again almost the same question. Sinchana, hi Sinchana. Mansi is saying 3A. Mansi is saying 3A. Komal went to option 4. Subbu, we are at question number 3, not yet 4. Okay, so try to answer 3 first. So Mansi answered correctly. Option 3A. Aluge Depo is saying, sir, where can we find important 2, 3 and 5 marker question? Can you please make a series on these two? Yes, definitely we will be making. It is coming very, very soon for all 2, 3, 5 marker video. We are doing it for your FA2 and then we will be doing it for your pre-board as well. Worry not. First we are starting with your FA2. FA2 exam is near. So we will be releasing that video by next Monday. And then you will also get your pre-board video by the time your FA2 is almost midway. We will also give you the all important question that is true for your pre-board as well as your board exam. Okay, same set of questions you can use for your pre-board as well as your FA2 exam. Worry not, all important questions, and we do not give extra question. That is one thing about us. Our channel do not give you a lot of questions to study and saying that okay, we have given you 100 questions, 10 questions came from that, we are genius. No, if 10 question is coming, we will maybe giving you 20 questions. Okay, I have seen some other people, they are giving you a lot of questions to study. We do not do that. That is our reputation. You can check with your seniors as well. So obviously in the absence of electric field, the average velocity of electron will be zero. Now let's see question number 4. Ohm's law is valid when the temperature of the conductor is. Ohm's law is valid when the temperature of conductor is very low, very high, constant, varying. I think most of you have answered this question correctly. Yes. Mayuri is saying my FA2 exams are coming from 17 onwards. Yes, most of the students are having starting from that date only. So that will also be taken care in our channel. Don't worry, we will give you all the important questions, all the solution for those important questions as well. What else you want? So 4C, Komal is saying 4C, Sinchana 4C, Mansi 4C. Darshan came and saying, I am preparing for preparatory exam, sir. I have tomorrow college level preparatory, so attending today is difficult, sir. From tomorrow, pakka no miss. Okay, Darshan, no problem. But do not miss out this session because we are going to discuss all the important MCQs. Some MCQs can be tricky. Okay, so obviously this is constant. Ohm's law is only valid when the temperature in the conductor is constant. Okay, it is not valid when the temperature is very low and very high. That is one of the drawback, right? Now, in the equation AB equals to C is the current density, C is the electric field, then what is B? Okay, AB equals to C, A is current density, C is electric field, then what is B? So, current density is J, B is unknown, and C is electric field. So, what is the value of B? What is the value of B? Resistivity, conductivity, resistance, potential difference. So, Nagraj, welcome Nagraj. MW Bangwan and Komal, Nagraj, also Mansi, everyone is saying 5A resistivity, yes. So we know that J is equal to sigma E. Here sigma is called conductivity, but when you take on the other side, it becomes J by sigma equals to E. Now 1 upon sigma is basically your resistivity, so it will be J rho equals to E. So rho is the resistivity over here, so definitely the answer is resistivity. This is also an easy question. In fact, this question is one of this question came in the past in KCET exam. Which of the following is non-ohmic resistance? So you have to identify a non-ohmic resistance: lamp filament, copper wire, carbon resistor, semiconductor diode. Which is non-ohmic? 6D, yes, semiconductor diode is non-ohmic. Lamp filament remains ohmic up to certain temperature. If temperature goes higher and higher, the lamp filament generally tends to deviate from Ohm's law, but at a certain temperature, generally lamp filament is considered to be ohmic. Copper wire and carbon resistors are ohmic, obviously. But semiconductor diode is not a ohmic at all. So that's why this is the answer for this question. Now next question, another easy question. The relaxation time in conductors. Most of you have answered that correctly. By the way, I forgot to take the names. Komal, Nagraj, Mansi, Moyuri. So now Mansi is saying 7A, Komal is saying 7B. Let me read the question. And Nagraj is saying 7B. The relaxation time in conductors increases with the increase in temperature, decreases with the increase in temperature. It does not depend on temperature. All of a sudden changes are 400K. So this is definitely not correct. Okay, this kind of things we have not studied. Okay, and it does depend on temperature. So this is also incorrect. So either 7A or 7B. Now, relaxation time is same as your own relaxation time. So, and temperature is like the days of between you and your final exam. So what happens to your relaxation time when your exam appears closer to you? So as your exam comes closer, everyone asks you to study. There is no relaxation time, no Instagram, no Free Fire, no playing games. Just go and study. So your relaxation time decreases as your exam approaches, right? So as the temperature increases, the relaxation time of conductors also decrease. It does not increase, it decreases because they collide more faster. Okay, if you increase the temperature, the collision becomes more frequent and the time between two collision is reduced. So that's why the relaxation time is decreased. You can take this analogy with you and you can remember it forever. Okay, so relaxation time is same as your own relaxation time, and the temperature you can consider it to be equivalent to the distance between you and your exam. Okay, more closer to your exam, your relaxation time is gone, right? So your FOT exam will come and you'll say, oh, I have to study, I don't have time to play or watch some reels, right? So that's why you can remember it like this and you will remember it forever. Now let's see the next question. With the increase in temperature of conductivity, with the increase in temperature, the conductivity of semiconductors increases and metals decreases. Metals increases and semiconductor decreases. In both metals and semiconductor increases, in both metals and semiconductors decreases. So definitely last two options are not correct because they go in the opposite direction. And what is happening here? You are increasing the temperature. So if you are increasing the temperature, what happens? Komal Kaushik is saying 8A, Mansi is saying 8A, Nagaraj is also saying 8A. Mayuri, I am the maximum volume possible from my end. Okay, you please check, and I do not see any dropped frame as well. Try to check the volume of your device once. Okay, try to check the volume of your device once if you can hear or not. Okay. Now, so Sinchana, Komal, everyone is saying 8A. Let's see. With increase in temperature, conductivity of semiconductors increases and metals decreases. So definitely this is the correct answer. Okay, with increase in temperature, conductivity of metals decreases. Now let's move on to the next question. Drift velocity of electrons is due to motion of conduction of electrons due to random collision, motion of conduction electrons due to electric field E, repulsion of the conduction electron due to inner electrons of ions, collision of conduction electrons with each other. Now let's see. Komal Kaushik is saying option B, Nagaraj is also saying option B. So 9B is correct answer, motion of induction of electrons due to electric field. Easy question, right? Now let's move on. Constantan wire is used for making standard resistance. Constantan, manganese and nichrome, they are three wires. They are basically used as standard resistance. Why? Because of high melting point, because of low specific resistance, because of high specific resistance, or option D, negligible temperature coefficient of resistance. Let's see. Kushal is saying Ba. What is Ba? Mansi is saying D. Komal is saying D. Nagaraj is saying D. Yes, because they do not increase their temperature with they do not change their resistance with increase in temperature. That means if you construct a device in Bangalore and if you take it say in North Karnataka or in East Karnataka also, they will function as equally as they are supposed to do in Bangalore as well. Okay, so that means the negligible temperature coefficient makes them reliable and the value of resistance remains fixed, and that's why they are used in standard resistance. Now let's move on to the question number 11. The resistivity of a wire, have I marked it? Yes. The resistivity of a wire increases with the length of the wire, decreases with the area of cross section, decreases with the length and increases with the cross section of the wire. None of the above statement is correct. Let's see who can answer it. Nagaraj is saying option D, Mansi saying option D, Komal is saying 11D. Yes, so this is a question where none of the above statement is correct. This is a question where none of the option is correct. Why so? Because resistivity is dependent on material, okay, and temperature. These two things can change the resistivity. So if you are changing the material, say you are using an iron wire, you switch to copper wire, then the resistivity will change. If you are using it as let's say 20 degrees Celsius, you increase the temperature to 30 degrees Celsius, then the resistivity will change. Otherwise, resistivity will not change based on length or cross section. Okay, so none of the above statement is correct for this question. Now, N identical cells of EMF capital E and internal resistance small r are connected in series, and external resistance capital R is connected in series with this combination. the current through capital R is. What is the current through capital R? Okay, check the options. Small ne by R plus nr, ne by nr plus small r, e by r plus nr, ne by r plus r. Who say the answer? Mansi, Sinchana, Nagraj, everyone is saying 12, option A. So this is the correct answer. Why so? Because n identical each of EMF E, so total EMF should be n into E, total EMF should be n into E, total resistance should be nr. So what is the total resistance when R external is connected? It should be R plus nr. Series, everything is series, so just gets added simply. Okay. Now next question. If the terminal of a cell are connected to an external resistance, then the potential difference across its terminal is. If the terminals of the cell are connected to an external resistance, then the potential difference across the terminal is more than EMF of the cell, less than EMF of the cell, equal to EMF of the cell, equal to potential drop across its internal resistance. Okay. The terminal of a cell are connected to an external resistance. So we have a cell. Cell means obviously it has some internal resistance, and we are connected it to some external resistance. Okay, so you have connected it external resistance of say R. Then what will happen to the terminal potential? Terminal potential is the voltage, this voltage. What will happen to the terminal potential? Let's see. 13B. So Mansi, Komal, Sinchana, Ashel, Mayuri, and everyone is saying option B. Yes, less than the potential, less than the EMF of the cell, because of the internal resistance. Some voltage drop will be happen across the small r. So that means it will be less than the EMF of the cell. So correct answer is option B, less than the EMF of the cell. Kirchhoff's first law, that is delta I equals to 0 at a junction, deals with the conservation of easy energy, momentum, charge, angular momentum. Easy question. Sinchana already answered it. I hope most of you have answered it. Ashel also answered, Mansi also answered. Yes, it is charge. Okay, junction rule based on charge and loop rule is based on energy. Now, if the experiment of Wheatstone bridge, the position of the cell and galvanometer are interchanged, the balance point will change, remain unchanged, depend on the internal resistance of the cell and resistance of the galvanometer. None of these. Let's see. This is question number 15. This is question number 15. 15B. Nagraj, Ashel, Komal, everyone is saying Mansi, everyone is saying B. Okay, the relative position of the battery and the galvanometer does not affect the condition. Only the condition that affect the balance condition is that P by Q is equal to R by S or not. If that is satisfied, then the bridge will be balanced. No matter even if you change the galvanometer with the higher value resistance galvanometer or lower value galvanometer, or if you switch the position between cell and the galvanometer, even if you change the cell or not, okay, only condition for balance is P by Q equals to R by S. There is no other condition, and that will remain intact even if you exchange the positions. The mobile charge carriers in case of metallic conductors are electrons and positive ions, positive and negative ions, electrons and holes, electrons. Okay, let's see. The mobile charge carriers in case of metallic conductors are, this is not the mobile phone that you use, so it is not like the mobile phone carriers, Airtel, Jio, no, it is electrons or protons or positive charge or holes. Okay, so let's see. Mansi is saying B, Nagraj is saying D, Sinchana is saying D, Ashel is also saying D. So yes, correct answer is electron. In case of conductors, only electrons. In case of semiconductors, electrons and holes. Positive ions cannot move. They are too heavy to move. Okay, they are like very fat person. They are sitting in their chair and they will do nothing. Electrons are the naughty kid. They are always running. Okay, holes are also type of like electrons. They are also naughty kid, but that only in case of semiconductors. For conductors, only electrons. Okay. The mobile charge carriers in case of electrolytic solution are. So in mobile charge carriers in case of electrolytic solution, this is a slightly chemistry touch question. Okay, electrons and positive ions, positive and negative ions, electrons and holes, electrons. Okay, let's see who can answer this. The mobile charge carriers in case of electrolytic solution. By the way, electrolytic solutions are not ohmic in nature. Okay, and they are solution, they are liquid. 17B, Komal, Mayuri, Sinchana, Ashel, everyone is saying Sagar, Anmol Chopra. Welcome Sagar, you came late. So positive and negative ions, very important. This is positive and negative ions and not electrons and positive ions. Okay, because in case of electrolytic solution, there can be negative ions and positive ions, not only electrons. Okay, so both positive and negative ions can carry charge. So that's why positive and negative ions, it's not the electrons. Electrons do not play much role. Yes, when they are outside the solution, only electrons can carry the charge, but inside the solution, both positive and negative ions can carry the charge. Now the mobile charge carriers in case of ionized gas. In case of ionized gas, now you have a gas. Okay, so electrons and positive ions, positive and negative ions, electrons and holes, electrons. Okay, so it is a ionized gas. You are trying to check which one can carry charges. So Nagaraj is saying option A, Mansi is saying option A, Mayuri is also saying option A, Komal Kaushik is saying option A, Sagar is also saying option A. Yes, in case of charge, in case of gas, okay, when you ionize a gas, there will be always a positive ion and electron. Okay, when you ionize a gas, now in certain gas there may be positive and negative ions, but that is very rare. Okay, all the gases of natural gas that you consider because they are say oxygen, hydrogen, carbon, so in that case what happens is that gaseous molecules, they split into a positive ion and an electron. So electron and positive ion is the answer. Okay. The resistance of a conductor depends only on the length of the conductor, only on the area of the cross section of the conductor, only on the nature of the material, all of the other factors. So here we are talking about resistance and not resistivity. So Sagar is saying D, Komal is saying D, Mansi is saying D, Nagaraj is saying D, Ashel is saying D, Mayuri is also saying D. Yes, all the factors that determines the resistance. Okay, resistance is given by R is equal to rho L by A. So it depends, rho depends on material, rho depends on temperature, and it generally depends on length and area, obviously. Okay, so all three factors are important. So resistance of a conductor depends on all three of them. Now let's move on to the question number 20. Identify the wrong statement. Identify the wrong statement. Okay, so here we have 4 statements. One of them is correct, 3 of them are correct, one is wrong. Resistance of a conductor is directly proportional to the length of the conductor. So resistance of a conductor is directly proportional to the length of the conductor. Resistance of a conductor is inversely proportional to the area of the cross section of the conductor. Resistance of a conductor depends on the nature of the material of the conductor and temperature. Resistivity of the material of a conductor depends on the dimensions of the conductor. Which one is wrong? Which one is wrong? So everyone already answered. Sagar, Ashel, Mansi, Komal, Sinchana, Nagraj, Mayuri. Resistivity is dimensionless. Yes, and no, resistivity is not dimensionless, by the way. Resistivity has dimension. Okay, resistivity has dimension of ohm centimeter. Okay, the dimension of resistivity is not dimensionless. It is not a dimensionless quantity. Okay, but still it does not depend on length. It does not depend on length or area or any dimensions of the material. Okay, even though it is not a dimensionless quantity, it does not depend on dimensions itself. Okay, it depends on material and temperature only. Okay, it is a constant for a given material. It's a constant for a given material at a constant temperature, like constant of gravitation. Okay, gravitational constant capital G is not a dimensionless quantity, but it is a constant, right? So resistivity is constant for a given material at a given temperature. Okay, it is not a dimensionless quantity. Don't have any misconception about this. Current density is a dash and its SI unit is dash. Okay, option D is correct, but let's see this question. Current density is a dash and its a SI unit is scalar ampere per meter square, vector ampere per meter square. Okay, so the first thing you have to determine whether it is a scalar or a vector, and then find its dimension. So yes, Nagraj is saying 21D, Ashel is saying 21D, Sagar is saying D, Mansi is saying 21D, Nagraj. Guys, mention if you are answering one question, mention it once. Okay, Mayuri is saying option D. Okay, so option D is correct. Vector and ampere per meter square. It's a scalar quantity. It says a vector quantity, and its dimension is ampere per meter square. The correct expression for mobility is mu equals to E by tau m, mu equals to E tau by m, mu equals to E m by tau, mu equals to m tau by E. Let's see who can answer this. So if you are answering without cheating, then definitely this is going to be a good. This is question number 22. Komal is saying 22B, Sagar is saying 22D, Nagraj is saying 22B, Mansi is saying 22D, B. Okay, so correct answer is E tau by m. Correct answer is E tau by m. Okay, mu is equals to drift velocity per unit electric field. This is very important formula to remember. Okay, if you have seen, there is a question where it comes that starting from drift velocity, find the expression for conductivity of the material. From there you have to use this formula. Okay, E tau by m is the expression for mobility. Okay, so remember this, E tau by m. There is nothing there. It's except that you have to remember E tau by m is the expression for mobility. So those who are saying D is wrong. Here are two statements related to cells. We are still in the easy category, boys. We will come to HOTS and multiple choice questions after 25th is over. Here are two statements related to cells. The device used to maintain steady current in a circuit is called a cell. Okay. The potential difference between the terminals of a cell in an open circuit is called EMF. Okay, both statements are wrong. Statement 1 is correct and statement 2 is wrong. Both statements are correct. Statement 1 is wrong, statement 2 is correct. So the device used to maintain a steady current in a circuit is called a cell. The potential difference between the terminals of a cell in open circuit is called EMF. Let's see. Sagar is saying, but in answer it is D. Sagar, so if you are answering from your answer, then definitely you are doing something wrong. Answer maybe it is given as D, but they have made a mistake. You should not. Okay, the teacher who will evaluate your paper will not make a mistake. So don't have a wrong perception. In answer maybe they will give D, maybe they will give A. It does not matter. You should always know the correct answer. Okay, correct answer is E tau by M, not option D, M tau by E. Okay, it is E tau by M. So Nagaraj is saying 23C, Mansi is saying, Nagaraj answer once and Komal also. Sir, in case open circuit, if there is closed circuit, will it be? I don't understand your question, Komal, Kaushik. So option C is correct. Both statements are correct. Okay, first of all, let us understand what is a open circuit means. Open circuit means, suppose you have a circuit. Okay, you have a, let me use this space. You have a circuit. Okay, this is a cell. This is the open circuit. That means no external resistance is connected. Okay, and you are not allowing any current to pass through it. Now there are ways to measure the potential at this point. Okay, one of the simplest way is to use a multimeter. Multimeter is a device, I hope you may have seen it in your laboratory. So if you connect the positive and negative of the multimeter over here, you will get the EMF of the cell. This is the easiest way to measure the EMF. But there are other ways. Potentiometer is one of the device which is specifically designed to measure the potential, and that is can also be considered as a open cell, open condition. Okay, so here you can measure the potential across the open circuit and you will get the EMF of the cell. If you, as soon as you apply a resistance in the circuit, okay, that will no longer be a open circuit, and that will not be a, you cannot say that is the EMF of the cell. So to measure the EMF of the cell, the circuit has to be open. Okay, so it's both open, and obviously cell is the device which used to maintain a current in a circuit. So both statements are correct. Now let's see the correct expression for conductivity of a material sigma, as symbols have their usual meaning. So there are 4 expressions: this one, this one, this one, or this one. This is a very common in derivation. Sagar is saying, explain again, 1 minute. Sir, in statement 2 there is a open circuit, but that place is there is a closed circuit. Will that statement be correct or wrong? That statement will be wrong. So if you make the circuit closed, that means you have to connect a resistor. Okay, and Sagar, I am explaining it again. So when no current is passing through a circuit, that is called a open circuit. That means for example, only a resistor, no cell is involved, that is the open circuit. So that is used to measure the resistance of a resistor. Okay, carbon resistor, for example, that you use in your laboratory to measure the doing some experiment. Okay, or the resistance box that you use. Okay, you remove something and you put say 1 volt, 2 volt, 5:2:2, that is the ratio, 5:2:2:1. So that's how you can measure the resistance if no current is flowing. If current is flowing, the temperature can increase, and based on that the resistance can change. That's why it is always suggested to measure the resistance, measure the voltage in open circuit. Open circuit means only the cell or only the voltage is connected. But when you connect an external resistance, say R, what happens is that the current starts flowing. Now if you measure the same voltage, it will give you the terminal voltage, not the EMF. So EMF, you will get some current in the circuit, that means some voltage is getting wasted in the internal resistance, and that's why you will not get the EMF, you will only get the terminal voltage. Okay, so that's that's why the statement will be wrong if you connect it in a circuit. Okay, for closed circuit this statement will be wrong, same statement will be wrong. I hope both of your doubts are clear. Right, now let's move on. Somehow I am not able to scroll. Okay, now let's see. So which one is correct? 24C, I see many of you have answered. Mayuri is now saying explain again. 23. Okay, 1 minute, Mayuri. Let me answer 24 first. So obviously this is a common derivation where we see that sigma equals to n e square tau by m. So correct answer is C. Now let's see the question number 23 again, the statements and the question. The device used to maintain a steady current in a circuit is called a cell. Any doubt about this statement? No, right? This is a correct statement. This is a correct statement, right? This cell is basically something that is used to maintain a current. So for example, if you are using a mobile phone, there is a cell inside, and the cell, if the cell is run out of the charge, the mobile phone will not work, right? So you for the cell to work, the battery has to have some charge. So battery is a collective term where more than one cell is there, right? We have learned that cells in series, cells in parallel. So battery is basically cells in series, multiple cells are connected in series. That's what is called a battery. But it is required to maintain the current, and the circuit will operate. Now second statement, potential difference between the terminals of a cell in open circuit is called EMF. Okay, so let's go back to this circuit. So open circuit means what? Open circuit means no current is flowing. No current is flowing. Okay, so this is called a open circuit. Here nothing else is there. This is called open circuit. And in open circuit, what happens is that no current is flowing. Now if you have some specialized device, I gave you one example of multimeter. If you have seen one, very good. If you have not seen, okay, you cannot use a simple voltmeter. Simple voltmeter has their own resistance. Simple voltmeter cannot be used to measure the EMF of a cell. This is also can be a question. Simple voltmeters cannot be used to measure the EMF of a cell. But if you use a specialized device, for example multimeter has a very high resistance, almost equal to infinity. So those kind of device can measure the open circuit potential, or the, if you just put the positive and negative across these 2 points, you will get a value over here, say 5. So this 5 actually represents the EMF. Okay, this 5 represents the EMF of the cell. EMF means when no current is flowing, actual value. Okay, so for ideal cell, there is no internal resistance, right? For ideal cell, if I say 5 volt, means it will always be 5 volt. Okay, whether it is connected in circuit, not connected in circuit, it will always be 5 volt. But if I say a cell, real cell, practical cell of 5 volt, this 5 volt will vary based on the external resistance that you have connected. Okay, because there is an internal resistance and there will be some current flowing in the circuit, and based on the current you will measure the terminal voltage. Terminal voltage is given by EMF minus current into the internal resistance. Okay, this is the most common term, and that will depend on the external resistance, because current in the circuit is changing based on the external resistance, and that's why different external resistance will give you different terminal voltage. So terminal voltage means voltage across. So for example, you have a battery, okay, normal AA battery, and you are trying to measure the potential across the 2 terminals. Terminals means positive and negative. You have seen a battery, right? If anyone has not seen a battery, no Sagar, multimeter, the name is there because multimeter can do multiple things. Okay, it can measure potential, it can measure voltage, it can measure resistance, it can measure some electronic gadgets impedances as well, and that's why it is called multimeter. Okay, it's a multiple device in one instrument. Okay, that's why it is called multimeter, not because its resistance is infinity. But yes, they have different terminals to measure voltage and to measure current. Okay, so there are generally 3 to 4 available slots are there. One slot is common, and another slot for current, another slot for voltage. For higher level of multimeter, there can be 1 or 2 more slots. Okay, so those who will study engineering, once you move into engineering colleges, this will be very common to you. You will say, sir, multimeter, you said we are using it in every day in our laboratory, right? So that will be very common to everyone. But nowadays, for now maybe it sounds something because you have not seen it very common, but you can ask your teacher in your laboratory next time you visit, sir, can you please show me a multimeter, and you can check that. Okay, this is a very small device. Small means like your mobile phone, little thicker. So open circuit means no current is flowing, and if you measure the voltage, you will get the terminal voltage. That is called the open circuit voltage. That is the EMF. But if you connect it in a circuit, for example, a real voltmeter real voltmeter has a high resistance, but it still has a resistance, and that's why you will get something less, say 4.9 or 4.8. So 4.8 and 4.9 is not the open circuit voltage, by the way. Clear? Any doubt about open circuit? Okay, Sagar is saying Mahi practicals are completed. Sir, multimeter reduced. I don't understand. What is multimeter reduced, Prajwal? Sir, is multimeter reduced? Multimeter does not reduce. Multimeter has effectively infinite resistance, practically infinite resistance, so it will not reduce. Okay, it will give you the exact voltage, almost exact. If not 5 volt, it will give you 4.99. Okay, so that is very close, and you can assume that 4.99, if you round it off, you will get 5, right? So multimeter will give you a very close actual value of the EMF. Okay. 26C. 26C, we have not yet come here. First answer 25. Kirchhoff's loop rule is based on the law of conservation of energy, momentum, charge or mass. I have already answered the question. I am asking, is it reduced from the syllabus? No, Prajwal, it is multimeter is not there in your syllabus at all. It is there in your practicals. Okay, some colleges use multimeters during your experiments. Okay, you can use that to measure voltage and current. That's how you might have seen it. If you have not seen it, if you are still using the old voltmeter and ammeter, that is also fine. Okay, some institutes do save some money by using multimeter, because it can be used as a voltmeter, it can be used as an ammeter. Same device can be used for multiple tasks, and it gives you a more accurate value. Okay, that's why multimeters are some colleges do use. Otherwise, multimeter was never there in your syllabus. Those who will study electronics may be there in your syllabus. What is the construction of multimeter? When I was a student, I have seen multimeter during my college. I was performing experiments using multimeter. I don't know exact working of a multimeter, if you ask me honestly. Okay, but I know basics of multimeter. Okay, what is the working principle I know, but the construction I have no idea. So Kirchhoff's loop rule is based on 25, question number 25. Yes. Okay, option A, option A, option A. Yes, Kirchhoff's loop rule is based on energy. Now let's move on to question number 26. Column 1 gives the physical terms associated with the flow of current through a metallic conductor. Column 2 gives some mathematical relations involving the electrical quantities. Match the following. Okay, so let's see the match the following. Relaxation time, drift velocity, current density, electrical resistivity. Here we have any by any Vd, E by J, M by any square rho, E tau by M. Now what we know is that, first of all, current density. Current density is what? I by A. What is I? I is NE A Vd by A. Okay, so first start with the quantities that you know. Okay, the match the following can be tricky if you try to match everything. Okay, current density number 3 is matching with A. Okay, and we will straight away go and check what are the matches with number 3 with A. How many matches are there? So if you see that number 3 matching with A, matching with not A, again this is only matching with A, this is also not matching. So whatever is not matching with A, we can simply ignore them. Only one which is matching with A is B. So 26 will be option B. 26 will be option B. Sunita, no, not option C. So Sagar also, it should not be C. Okay, if you see C, 3 is not matching with A. Okay, so be careful. Current density is given. How can current density be matched with current density? Okay, so check the options once. Okay, you will not be, I can guarantee that during the heat of the exam, if match the following type of question is coming, you will not be able to match all the quantities for sure, unless it is a very easy match the following. Okay, maybe it's you are appearing for KSET also this kind of question is common, or in your board exam. So if you see a match the following, it will be difficult for you to match all the followings. but make sure at least 50% of them you can match. Okay, for example, electrical resistivity can be matched with this one. Okay, so these two matches you have to be sure. Okay, current density is any Vd and electrical resistivity is E by J. So based on these two matches, you check any direct matches are there or not. If not, then you have to take a guess. Okay, in that case you have to be careful that relaxation time should not match something which has relaxation time. So this should match with C. This is a general knowledge, and drift velocity should definitely be this one. Okay, that is also a way to answer. Tau is relaxation time. So relaxation time itself cannot be matched a quantity which already has a relaxation time. Similarly, drift velocity, current density should not be matched with something which already has a current density. That's how you can eliminate. Okay, so this is a smart type of answering. Okay, as I mentioned that if you are believing that I can match all the followings, it will be difficult. First, start with one of the easiest one, and then check if there are unique, this matching is unique or not. If this is unique, fine. For example, we only matched one, that is current density with A, and we found this is unique and our answer is sorted. But in that case, suppose here also you got option A is matched over here, then you have to check the other matching and see. Okay, I recommend at least 50% of the matching you should do. Now this is also a difficult question. We are in the difficult territory, right? The resistance of a wire is R ohm. If it is melted and stretched to n times its original length, its new resistance will be. Now those who have seen my cassette lectures, they should be able to answer it. Sagar, don't worry. Don't worry, wrong answer is fine as long as you understand the reason. Okay, if you are saying that no, I answered wrong and I am correct, then it is something you need to change. Okay, then it is your problem. Otherwise, if you have understood that okay, my matching is wrong, why it is wrong, I have understood the concept, then you should be able to do well in your exam. So you should learn from your mistakes. So as long as you are learning from your mistakes, that is well and good. That is before, because this is not your exam. This is not your final exam. So in your final exam, whatever mistakes you are making will not be making there. That is what important. So let's see. Resistance of wire resistance R is melted, and now the new length is n times. What will be the new resistance? Yeah, Y 27B. So most of you are saying 27B, and Mansi is saying 27D. So only Mansi and Donald Prakash. Mansi and Donald Prakash are correct. It will be option D, n square R. Okay, remember this. When you are stretching a wire, I told you multiple times, those who have seen my, that means many of you have not seen my cassette lectures. If you are stretching a wire or recasting it and changing its length, okay, and making it n times, remember that whenever you do so, what is happening over here is the width of the wire. The width of the wire is also changing. That means the surface area also changes. So when you recast the wire and change its length, okay, its surface area also changes. We know that resistance is given by rho L upon A. So if L length becomes n times, if length becomes n times, its area becomes 1 upon n times. Okay, so remember this very well. The length becomes n times means area has to become 1 upon n times. So that means the overall resistance, the new resistance, will be n square old resistance. Okay, this formula we have used in solving questions. So the length of the wire is doubled. What will be the new resistance? It will be 4R, not 2R. Okay, length of the wire is halved. What will be the new resistance? It will be R by 4. Okay, remember this. This is a very useful and intelligent formula, and not only for your PU board exam but for your cassette exam as well. Okay. Now let's see the question 28. So those who have answered this wrong, are they clear about it? Komal said 27D. Komal, I missed maybe in long behind because Sunita also answered Donald Prakash saying option D. Donald Prakash Chopra. Oh, Sagar Prakash Chopra. Donald Prakash Pinto. Okay. 28A and Sagar is saying 28D. Let's see. Statement 1. When a wire is not connected to a battery, then no current flow. This is looking to be a correct statement, right? No battery means no current. In the absence of electric field, free electrons moves randomly or does not move in a particular direction. So this statement is also correct. So in the absence of electric field, electrons move but does not move in a particular direction. The motion is random. So both statements are correct. Now let's see. Both statement 1 and 2 are true and statement 2 is correct explanation of statement 1. Yes, both statements are true, and because the no battery means no electric field. Okay, battery is the source, so battery provides the required electric field. So no electric field means all the electrons are moving in random direction. That means no current is flowing. Okay, so both statements are true and it is a correct explanation. So 28A, those who have answered are correct. Yes. Okay, Sagar is saying I said 27D. 27 we have solved, Sagar. Nagaraj is saying 28A. Donald Prakash, Donald, don't spam answer once. I will definitely try to take your answer. Achin Kushal is saying hi. Hi Achin. Try to answer the questions. Right. And if you are first time watching this channel, don't forget to subscribe. Okay, subscription is very, very important for us. So if you are watching for the first time, try to subscribe our channel. Now, which of the following is different from the others? Volt square per ohm, ampere square ohm, volt square per ohm, okay? Ampere square into ohm, volt into ampere, joule second to the power minus 2. Which one is different? This question is easy, by the way. As I mentioned, if you have seen, I have done another session where I take the same question. But if I am a paper setter, I will give you a complete different option so that it will be difficult for you to understand what topic they are talking about. Okay, so if you are answering it, try to tell me what is the topic, what quantity we are saying. Three quantities represent the same thing. What is that quantity? Komal Kaushik answered 29D. Anyone else want to try? Yes, Nagaraj, correct. Power, we are talking about power. Volt square per R, V square by R is power. I square R is also power. V into I is also power. And joule per second is power, but not joules per second square. So here you can odd man out. You can answer this D, because even if you don't know, suppose you are a complete a student who have not studied anything, you see everything has volt ohm, volt ampere, that means something is related. This is completely different unit, so I will mark it. Joule second has nothing to do with volt ampere, so they can still get it correct. Okay, but if I am setting the question, I will change here volt into ampere square I will do, and here I will make joule per second. Okay, so then it will be difficult for you to neglect. If you answer joule per second wrong, then you will be incorrect, because joule per second is the unit of power. Okay, joule per second square is not the unit of power, but joules per second is the unit of power. Okay, any doubt in this question? Otherwise we will move on to the next question. When a steady current flows through a metal conductor of non-uniform cross section, then the drift velocity is independent of area of cross section, directly proportional to the area of cross section, inversely proportional to the area of cross section, inversely proportional to the square of the area of cross section. Mansi, electrical power, yes, three of the quantities here are electrical power. Okay, and unit in terms of dimension or in terms of unit, you can say that electrical power and mechanical power are same. okay, in terms of dimension or unit. So you can even represent electrical power as unit of watt. Watt is joule per second. Okay, so that's why the bulbs are rated at 100 watt. Nowadays we use CFLs or LEDs 9 watt, 10 watt, 12 watt. So watt is the unit of work, power, but it is a mechanical power. But same unit can be used in electricity as well. Now let's see question number 30. 30C, saying Muhammad Dhanif, Mansi is saying C, Komal Kaushik is saying option C, and Sagar is saying C, Sunita is saying C, Sinchana is saying C. Okay, Muhammad Dhanif is saying S for some reason, I don't know. Otherwise everyone is saying C. So inversely proportional to the area of cross section. Okay, so we know that steady current flowing through a circuit can be given by I is equal to NEA VD. So from here, I is steady means constant, number density is constant, charge of an electron is universal constant, and here area and VD. So here we can say that VD must be equals to I upon NEA, that is VD is inversely proportional to area. Okay, so correct answer is inversely proportional to area. Now this is very interesting question. Okay, this question actually is taken from your cassette paper, one of the old cassette paper. Consider a thin square sheet of side L and thickness small t, made of material of resistivity rho. The resistance between two opposite faces shown by the shaded areas in the figure is directly proportional to T, directly proportional to L, independent of T, independent of L. So here we have a sheet of metal. Okay, the thickness is given here as T and the length here is given as L, and we are measuring the resistance between these two sides. We are measuring the resistance of these two sides. So they are saying directly proportional to T, directly proportional to L, independent of T, independent of L. Okay. Now this is a square sheet. Square sheet means if this length is L, this will also be L. That is not given in the question, that is the hint I am giving it to you. Now answer again. If you have answered it, now answer it again. Answer is very, very interesting. Komal saying 31D, Mansi is saying 31D, Marudesh is saying B, Sunita is saying D, Mayuri is saying D, Sinchana is saying D, Anmol, Sagar Anmol is also saying D. Now D is correct answer. It is independent of L. But why it is independent of L? Can anyone tell? Because this is the square sheet, so it should be directly proportional to L, but it is independent of L. Why? So for that we have to go into the equation of resistance, which says that resistance is given by rho L by area. Okay, rho L by area. So here if you see that this is length, so L is here, but what about the area? So this is the area, right? This is the area of the cross section. So what is the area of cross section? Area of cross section here is a square, not a square, it's a rectangle. So rectangle of length L and width T. So here area will be rho L by L into T. Okay, so L will cancel and you get rho upon T. So it is inversely proportional to the thickness T. So resistance is inversely proportional to thickness T, but it is independent of the length if it is a square sheet. This is only valid when this is a square sheet and lengths will cancel. That's why it is independent of length L. Identify the wrong statement. Again, wrong statement we have to identify. Drift velocity acquired by charge carriers per unit electric field gives their mobility. metallic conductors with increase in temperature the resistivity increases. In semiconductors with the increase in temperature the resistivity decreases. The temperature coefficient of resistivity of metallic conductors is negative. So identify the wrong statement. Sagar, no. Sagar, we cannot use any other language than English in our channel. Okay. I am extremely sorry. We know there are a lot of students who are from Kannada background, so they will ask, sir, please teach in Kannada. Someone will say teach in Marathi. So that is not possible. We will continue. Our main language is English, and we will try to continue with that. Okay, there are some other channels, they teach in Kannada and English, but we prefer English. That's what we are going to do over here. So Komal Kaushik is saying 32D, yes. So all three statements are correct. Drift velocity acquired by charge carriers per electric field is given by mobility. So mobility is Vd by E, that is true. Metallic conductors with increase in temperature resistivity increases, yes, this is true. In semiconductors with increase in temperature resistivity decreases, that is also true. The temperature coefficient of resistivity of metallic conductors is negative, this is not true. The temperature coefficient of resistivity of semiconductors is negative. What is the meaning of this term negative resistivity? Negative resistivity means if you increase the temperature, resistance decreases. But that does not happen in conductors. It happens only in semiconductors. For semiconductors, you can say this statement is true, but not for conductors. Next question. In general expression for resistivity, a material is given by rho equals to mn square tau. Symbols have their correct meaning. Identify the correct statement. Okay, again, correct statement means 3 are incorrect, 1 is correct. In metals with increase in temperature, n remains constant, tau increases. In metals with increase in temperature, n remains constant, tau decreases. In semiconductors with increase in temperature, n decreases, tau increases. In semiconductors with increase in temperature, both n and tau increases. Okay, let's see. Option B. So everyone is saying Komal, Donal Prakash, Mohammad, Sunita, Mansi, everyone is saying B. Yes, in metals with increase in temperature, number density remains constant and tau decreases. We already learned that relaxation time decreases with increase in temperature. So definitely that is the correct statement. Now one interesting point, in semiconductors with increase in temperature, okay, tau always decreases, no matter it is a semiconductor or conductor. But in semiconductors we know that the resistivity actually decreases in semiconductors. Why? Because the number density increases many times. In semiconductors, when you increase the temperature, the number density increases many times. So even if tau changes, tau decreases, okay, because number density increases many times, okay, the resistivity decreases many times because rho is inversely proportional to n. Okay, but for metals, n remains constant, tau decreases, that's why resistivity increases. Clear? Even though we have not discussed semiconductors yet, but you should have that idea. Some physical quantities are listed in column 1 and their dimensions are listed in column 2. Again, I match the following type question. Resistance, current density, resistivity. Which match is correct? Okay, so again first we will try to find the easiest one. Okay, the easiest one is current density. Current density is the easiest quantity, that is J. It is given by current divided by area, so its dimension must be A L to the power of minus 2. Okay, A is area, here A is area, here A is current. Okay, so don't get confused. So L to the power of minus 2 is current density, so definitely this is matching with this. Okay, now which one is resistivity, which one is resistance? That is most important part. Sir, my physics ma'am uses legend study material but does not teach in a understandable manner. Yes, Legend is a good book. Okay, especially if you consider the handbook part in Legend is good. Okay, Jeevit is also one of the book. So when I used to teach in college directly to the students, I used to have Legend for PU board exams. So that is a good material for PU boards. Okay, but Jeevit is also good because they also give you the list of questions for last PYQs. So that is also a good way to study. Any one of them you can study, you can use for your PU preparation. But I am here, no, I will try to help you as much as possible, right? So many of the students are saying, let's see, as I said, try to check one match first. Current density is matching with L to the power of 2 minus A. So 2 is 1 with A is matching twice. So either this one or that one. Now one more trick. Generally the matching is not straight away. Okay, resistivity should not match with C, so resistivity should match with B and resistance should match with C. This is a way to check your answer. Okay, that is most general. There are some cases it can go wrong. Okay, it can go wrong, but this is also a way. 90% cases direct matching does not happen. But anyway, let's see resistivity. Which one is resistivity, which one is resistance. So first we will start with resistance. Resistance is rho L upon A. Okay, so whatever is the dimension of resistivity times another extra length. So whatever the dimension of resistivity times one extra length is the dimension of resistance. So here if you see that this one has 2L, this one has 3Ls. So definitely this is resistance, this is resistivity. So this is resistance and this is resistivity. Even though my trick does not work in this case, but if you are not sure at all, just want to take a wild guess, then you can do that kind of matching. That might work in 90% cases. This case it does not match, but here we know that resistance and resistivity are differed by only 1 L. So resistance should have 1 extra L compared to resistivity, and comparing these two quantities we see that only this one has extra L. So definitely option C is the correct answer. So 34C is correct answer, not 34D. Nagraj. So that's why I said 34D would have been correct answer if my trick worked, but my trick does not work in this particular question. So if you want to take a wild guess, yes, Komal, Jeevit is a good book. Sunita is saying Legend is also good book. There one book I don't want to name that book. I have seen many students use that, a thin book written by a particular publisher. Okay, that book is very bad. They just give you very minimum answer for each question, which is sufficient to pass but not for scoring good marks. That book is good for the students who are going to fail in the exam. So if they just want to pass, they can study that book. But for if you want to score 80-90%, that book you should not follow. Now what is the name of the book? I will not tell you, you should guess. Now the graphs representing the variation of resistivity of different materials with temperature are given below. Identify the correct option. So here we have 3 graphs. Okay, and graph 1 is for semiconductors, graph 2 is for metals, graph 3 is for alloys. Okay, graph 1 is for metals, graph 2 is for alloys, graph 3 is for semiconductors. So either one of them is conductor, one of them is alloy, and one of them is semiconductor. Which one is what? That you have to guess. No, not Dinesh or Vinesh. Yes, Donald Prakash is correct. Study for your success is also correct. Study for your success is saying, sir, MCQs are solving, but what about other parts? Are you providing questions or anything? Study for your success study, you can check our Brahmastra series. It is a comprehensive series. MCQs we are discussing there only 15, but all the other important questions for 2 marker, 3 marker, 5 marker according to your blueprint. Okay, according to exactly your blueprint we are discussing there. You can go and check that out. Otherwise, we will also provide you a comprehensive videos where you can see all the 2 marker, 3 marker, but that will take some time. You can check our Brahmastra. If you watch our Brahmastra, and someone asked us yesterday, sir, if I watch your Brahmastra and this series, will I be scoring 90%? You should score out of out if you watch Brahmastra and this series. These two are complementary. So if you watch those 2 series, this series and the Brahmastra, you should score out of out, no doubt about it. Okay, study your success. Now let me please tell me the answer for this question. Sir, please check once resistance dimension. Komal Kaushik is saying please check resistance dimension. So resistance, okay, if you want me to check the resistance dimension, let's see. So what is resistance? Resistance is V upon I, right? Resistance is V upon I. Now what is V? V is work, right? Voltage is work per charge, per unit charge, okay? Or you can say that if what I will do, I will use a slightly separate thing. I will use V into I divided by I square. What is V into I? V into I is power. V into I is power. Do not take the dimension of voltage, because voltage can be confusing. Voltage is not work done, by the way. Voltage is work done per charge. So you have to divide it by multiply with time to convert it current again. So better to take V into I. Okay, so V into I is work, right? That yes, work. That is what I am saying. V into I is power. V into I is power. What is the dimension of power? Dimension of power is M L square T to the power of minus 2 into So power is force into displacement divided by time. Okay, so power is force into displacement divided by time, that is work done by time. Now force is ml t to the power of minus 2 and another L from x divided by t. So power is m L square t to the power of minus 3. Okay, so if you put it over here, you will get ml square t to the power of minus 3. ml square t to the power of minus 3 and divided by a square. Okay, this is the dimension, so you will get ml square t to the power of minus 3 a to the power of minus 2. So this is the dimension of resistance. Okay, and resistivity will be resistance into area divided by length. So that will be R into dimension of L. Yes. So sorry, I made a small mistake here. It should be resistance by L. So yes. So this will be the dimension of resistance and this will be the dimension of resistivity. Yes, correct. So match will be not C but D. Nagaraj answered D. I scolded him saying that you are wrong. No, it is correct. Okay, so yes, this is correct. So resistivity is m square L to the power minus t to the power of minus 3 into a to the power of minus 2, and this is resistance, and resistivity will be ml cube t to the power of minus 3 a to the power of minus 2, right? Thank you, Sagar. SPR is a publication that publish books for Donald Prakash, don't read from that book because the overall quality of that book is not good. Okay, don't mind, but that book is good for you to score 50% overall. That means 35 to 40 marks you can score by studying that book, but 70 out of 70 or even 60 you will not score from that book. Okay, the quality, overall quality of that book is very poor. The numericals given in that book are not good. Okay, but that can be a reference book. If you want to see which year, which questions are coming repeatedly, that you can take from that book. Okay, that is a good reference book where all the years are mentioned, all the previous years are mentioned, even repeated questions are also mentioned. Okay, that is a good way, but the answers mentioned in that book, don't study from there. It will not be sufficient, okay? Because every long answer type question they mention is only 1 or 2 words, which is very, very wrong, okay? So even though that is a good reference book, you should not make it your main book to study for your PU. Please don't mind, but that is a fact. So now last question. 35, which was correct? By the way, Sagar and all of you, the answer is option D. So my trick, whatever trick I have used is correct. Okay, so the trick is correct here. Now let's see the question number 35. Either you follow NCERT, which is a lot of syllabus to cover, or you follow the handbook portion of Legend, or you can follow the handbook portion of Jeevit as well. Okay, both are good. Handbook portions are not that big, but the question answers are standard in both books. Okay, so the graphs representing the variation of resistivity of different materials with temperature are given below. Identify the correct answer. So this is resistivity is increasing with temperature, that means this is metals. This is almost constant, that means this is alloy, and this is decreasing, that means this is semiconductor. Okay, so correct answer for this question is graph 1 is for metal, graph 2 is for alloys, graph 3 is for semiconductors. So correct answer is option B. Now if you want, I can solve the fill in the blanks as well. There are 2 sets, I will solve it, but it will not come in your board exam. Study for your success, sir. Give Brahmastra series notes of drive link, please, sir. We need it. I am requesting you. Study for your success. I will request our admin to provide the link to you. It will be shared in our WhatsApp channel, by the way. So if you are not part of our WhatsApp channel, don't forget to join the WhatsApp channel. There I will give you the link very, very soon, by tomorrow. All physics published lectures will be provided there. Okay, and other subjects, the teachers, I'll ask them to upload the PDFs as well. Okay, how to prepare for FA2? Sagar, Monday video is coming on FA2 physics, and then after that all the other subjects will follow. So Monday physics is coming. Okay, that I know. FA2, all the important questions, important answers, everything will be discussed in one video. One video I will give you for questions. Some students don't want answers, they want the questions to check whether they know the answers. So that will go on Monday, and then there will be a question for a solution for all the questions that I have given. Okay, so everything will be discussed, covered. If you watch this video, you score 30 plus in FA2. Congratulations. Okay. So second quarterly on second week and Jan 2 preparatory, how to study? Study for your success. Don't worry, don't think how to study, start studying. Okay, continue studying, definitely you will be able to overcome that. Okay, you know there will be 2 preparatory, one preparatory on January 2nd, one preparatory will be January 17th or 18th, I think. But that time those who are appearing for JEE, they will not be able to attend because they have to go for JEE exam, right? What does FA2 mean? Can anybody say how many marks though? Komal Kaushik, FA2 is formative assessment number 2. So this will be a 35 mark question. So if you are from Karnataka board, Then there are two formative assessments that happen. One is FA1 that you gave long back, okay, before your midterm exam, FA1, okay, formative assessment 1, 35 marks. Then you give your midterm exam. Now this is formative assessment 2 of 35 marks again, and after that there will be preparatory exam directly. Okay, now for subjects such as Kannada, English, mathematics, FA1 and FA2 marks are important because those percentage of that marks goes to your 10 marks internal. Okay, 10 marks, there are 20 marks, 10 marks is for your project and 10 marks is for internal. So that internal marks is basically combination of your FA1, FA2, midterm and your pre-board exam. So combining all three, there are best of 2 exams that is considered, and 10% of that marks, that is 10 marks is taken for your board exam as well. So 20 marks, and that you get 10 marks is from your project, 10 marks is from the internal marks. Internal marks is calculated from these exams, and anyway these marks are there in your SATs. That is recorded against your name. So in case suppose your paper is misplaced during your board exam, suppose your final paper is misplaced, then they can give you 2 options. Either you have to appear for the next exam, or if you don't want to appear for the next exam, they take the result average marks based on your previous exams that you have given. Okay, so this is the thing. Sagar is saying I got 10 marks in internal. 10 marks, that means you are saying the project marks. 10 marks internal will be automatically calculated, the other 10 marks. Okay. Yes, Komal. Everything is considered. Okay. So anyway, almost 7. So 1 hour 30 minutes is over. So anyway, you might get some fill in the blanks in your FA2 exam from this chapter, but it will not come in your PU final exam, because according to the blueprint, as I discussed first, this chapter does not have any fill in the blanks, only MCQs, and MCQs, as we have seen, not very easy. Some of them are easy, but last few MCQs are not easy. They require some time to solve. Okay, so I'll be back with a new chapter. The schedule will be shared in our WhatsApp channel, so please join the WhatsApp channel if you have not joined. Nippan Kali Singh, sir, give PDF 2, 3, 5 marks question and answers which are in question bank. You don't need to study the entire question bank unless you have a lot of time. Okay, the exact questions that are going to come in your PU exam, pre-board exams and your FA2 exams are already covered in our Brahmastra series, which is a continuous series. Almost 50% of the syllabus is covered, and remaining 4-5 chapters will be covered by end of December. So all the chapters will be covered by then. So you can follow our Brahmastra series, and PDFs are not yet available for Brahmastra series, but I will make sure the PDFs are reaching you very soon. So don't worry about it. Okay, you don't need to study, because the question bank is shared, is actually a future proof question bank. So in future, suppose they change the question pattern, they change the blueprint, the same question bank they can use for the reference of their teachers and the reference of the any paper setter. That's why question bank is very exhaustive. Okay, you don't need to solve the entire question bank unless you have a lot of time, because question bank 14 chapters for physics, that the size is huge. Okay, what we are doing in Brahmastra, all the important questions which are repeatedly coming in your PU2 exams, those questions and along with their solutions are discussed, so you can go and check that out, right? And Ninga, study for your success. I've started studying. Please just provide notes for Brahmastra series. You should check the Brahmastra series as well, so that our views goes up, right? Study. In our college, they will not disclose project mark. Oh, okay. I scored 10 marks from the test and midterm. Oh, wow, good. Sir, how we join for WhatsApp channel? Sunita, the WhatsApp channel link in the description section. Close the live chat. Go to the description where it is written more. Okay, so you will see that Diksha Karnataka, okay, students are watching. Then you can go to the more section, and then you can click on more, and there you will see a link given tinyurl.com/dk. Okay, that is our WhatsApp channel. You can click and there you can directly join. Okay, Sunita, right? You can close the chat, go to the description of the video where it is mentioned more, click on the first more, something will open, click on the second more, and go down below, you will get the WhatsApp channel joining link, right? Okay, so I'll close this chat. It is almost 7 now, and I will be back with first of all your FA1 preparation, FA2 preparation videos are going to come in next week. Also I have to prepare for that. There will be one Brahmastra this Sunday as well. Don't miss out on that. If you are preparing for FA2, the chapter which are going to discuss on this Sunday is important for your FA2. So with that note, I like to end this session and see you soon. Till then, bye.